Welcome to Daily Papers, the podcast where we break down interesting new research papers into something you can actually understand. Today, we're heading out to the open ocean, at least figuratively. We're talking about a new way to keep an eye on wildlife, and it involves a team of autonomous drones.
Which sounds very cool and also very complicated. The paper is called Decentralized Vision-Based Autonomous Aerial Wildlife Monitoring. It's a bit of a mouthful, but the core idea is actually pretty intuitive. Imagine you're a marine biologist, and you want to study a pod of sperm whales. These animals are huge, they cover vast distances, and there can be dozens of them. How do you track them all at once?
Right, you can't be everywhere. You could maybe have a few people in boats or a plane, but that's expensive, disruptive to the animals, and you're still only getting a limited view.
Exactly. So these researchers from MIT and Harvard thought, what if we used a team of drones? Not just one drone, but a whole swarm that can work together.
A drone swarm. Okay, my first thought is there must be a supercomputer somewhere, or a pilot with a very complicated controller telling all these drones where to go.
And that's the first really cool thing about this paper. There is no central commander. That's what the word decentralized in the title means. There's no leader drone, no pilot on the ground sending out orders. They figure it out all by themselves as a team.
So they're more like a flock of birds than a military squadron.
That's the perfect analogy, and it gets even more impressive. To keep things cheap and simple, these drones have only one main sensor, a regular camera, like the one in your phone. They don't use GPS or any other fancy location sensors to coordinate. They do everything just by sight.
Okay, that's genuinely impressive. So how does a team of leaderless, camera-only drones actually go from flying around to monitoring a specific pod of whales?
The researchers broke it down into a 6-step mission, and it all starts with just one drone.
The lone wolf, or I guess the lone drone.
Right. Step 1 is scouting. One drone is sent out to a promising area, and it starts flying in an expanding spiral pattern, scanning the ocean below. Step 2 is detection. The drone's onboard AI is looking for whales. Once it's confident it has found some, it triggers the next step.
Which is calling for backup.
Exactly. Step 3 is rendezvous. The scout drone basically shouts, "Hey everyone, party over here," and shares its location. The rest of the drone swarm then flies over to meet up.
Okay, so now you have a bunch of drones hovering over a pod of whales, but my drone is seeing the whales from the left, your drone is seeing them from the right. How do they know they're looking at the same animals?
You've hit on the trickiest and most important part. This is step 4, which the paper calls registration. The drones need to build a shared understanding of the scene. They basically have a conversation that goes something like this. I see a big whale at my 10 o'clock position. Do you see it?
But how do they talk to each other? You said it's all decentralized.
They do it very efficiently. They don't all chatter at once. Instead, they're set up in what's called a ring topology. Each drone only talks to its 2 immediate neighbors, like passing a note around a circle of friends. One drone says, "Here's what I see." The next drone compares that to its own view, adds its information, and passes it along.
So the information travels around the circle until they all agree. Okay, we all agree there are 9 whales, and we've all labeled them whale number 1 through whale number 9.
Precisely. Once they have that shared map and have identified each individual animal, they move to step 5, goal assignment. This is the drone job fair.
The job fair?
They have to decide which drone monitors which whale. And since there's no boss, they have to figure it out themselves. They use a special type of AI that's really good at team coordination to solve this puzzle instantly. The goal is to assign every whale to a drone in the most efficient way possible, so no 2 drones are trying to follow the same whale and no whale gets left out.
And once every drone has its assignment?
It's step 6, execution. Each drone locks onto its assigned whale and begins tracking it, recording video and data. The whole process from scouting to tracking is completely autonomous.
That is a seriously cool pipeline. But this all sounds great in theory. How did they test it to see if it actually works in the real world?
This is my favorite part of the paper. Getting permission and the logistics to test a new drone swarm over actual sperm whales is difficult. So they did the next best thing. They went to a soccer field.
A soccer field? To find whales?
They printed out giant posters of whales and scattered them across the field. This created a safe, controlled environment that mimicked the real scenario. They then deployed their drones and let them run the full mission.
So the scout drone went out, found the whale posters.
It did. It spotted the posters, called in the rest of the swarm. They all gathered overhead, figured out which poster was which, assigned a drone to each one, and then started monitoring them. The real-world test was a success from start to finish.
That's a brilliant way to test it. And it proves the whole system works. What does this mean for the future of wildlife monitoring?
This could be a complete game changer. The system is relatively cheap, just drones with simple cameras. It's scalable, meaning you could use 5 drones or 50, and because the drones are small and electric, it's much less invasive than a giant research ship or a noisy helicopter.
So scientists could get more detailed, continuous data on animal behavior without disturbing them. You could see how they interact, their migration patterns, their health.
Everything. And it's not just for whales. This exact same system could be adapted to monitor herds of elephants on the savanna or caribou in the Arctic. It gives researchers a powerful new tool to understand and protect endangered species.
Beyond the animals, the technology itself is fascinating. A team of robots that can coordinate and collaborate just by seeing the world around them has applications in so many other areas.
Absolutely. You can imagine using a system like this for search and rescue after a natural disaster, or for monitoring crops in agriculture. The core principles of decentralized, vision-based teamwork are incredibly powerful.
So by using a few drones, some smart AI, and some whale posters on a soccer field, this paper gives us a real glimpse into a future where technology can help us be much better guardians of the natural world.
A future where the robots are working together. For the whales, a pretty great thought to end on.
That's all the time we have for today. Thanks for tuning in to Daily Papers.